The question says that the transverse displacement of a string clamped at both ends is given by yxt equals to 0.06 sine 2 pi by 3x cos 120 pi t, where x and y are in meter and t is in seconds. The length of the string is 1.5 meter and its mass is 3 into 10 to the power minus 2 kg. Answer the following. Does the function represent a traveling wave or a stationary wave? Interpret the waves as a superposition of the two waves traveling in opposite direction. What is the wavelength, frequency and the speed of each wave? And the third question is, we have to determine the tension in the string as well. So it is not written over here, but the third question is, determine the tension in the string. Now in the first question we have to tell whether the given equation is representing a traveling wave or a stationary wave. So the given equation is in the form of yxt equals to a sine kx into cos omega t. This form represents the stationary wave. So this is a stationary wave, not a traveling wave. Now the second question said that interpret the wave as a superposition of two waves traveling in opposite direction. What is the wavelength, frequency and speed? We have to find out wavelength, frequency and speed. So a stationary wave may be interpreted as a superposition of two traveling wave in opposite direction. Now for a wave equation of the type a sine kx cos omega t, like it is in the question, using trigonometric identities, 2 sine a minus b plus sine a plus b equal to sine a cos b, we can rewrite using the trigonometric identities as yxt equals to a by 2 sine kx minus omega t plus sine kx plus omega t. Now where k is the wave number and omega is the angular frequency. By equating these two relations, we come to know that omega is equals to 120 pi radians per second. So omega can also be written as 2 pi times the frequency. Now frequency we can calculate as a 60 hertz. Similarly, we can find the value of k using relating these two equations. Now k would be equal to 2 pi by lambda, and where lambda is equals to 3. So from the given equation we have known the frequency and wavelength. So in third question, it's asking the tension in the string. Now the tension, the relationship of tension and the speed of wave in the string can be given by v equals to under root t divided by pi, t divided by mu, where mu is the linear mass density of the string. Now for calculation of v, because v is the unknown term here, v would be equal to lambda times the frequency. Lambda we know that it is 3 meter from the above calculation and frequency is 60 hertz. So the speed is going to be 180 meter per second. Now linear mass density mu is equals to mass per unit length. We have been given mass as 3 into 10 to the power minus 2 kg and length as 1.5 meter. So the mu value would be 2 into 10 to the power minus 2 kg per meter. Now substituting these values in the above equation relating velocity and tension, we get the value of tension as 648 Newton. Thank you.